For over 70 years, most of us were taught there were 9 planets in our solar system. We memorized their names, probably with a silly mnemonic. We built those school project models, carefully painting a tiny, faraway sphere and sticking it on the very edge of our cosmic family. Pluto was the last stop, the cold, distant punctuation mark at the end of our cosmic street. For generations, this was just a basic fact of science, as solid as the Earth going around the Sun. But then 2006 happened. In a controversial vote, a room full of scientists stripped Pluto of its title, kicking off a fierce, emotional, and surprisingly passionate debate that's still going on today. It felt personal, didn't it? Like a betrayal of everything we learned in elementary school. So what really happened to our 9th planet? This wasn't some quiet update in a textbook, it was a public takedown. We're going to get into the science, the discoveries, and the heated backroom arguments that led to Pluto's demotion. We'll look at the evidence, the fallout, and the fascinating reasons so many of us just can't seem to let it go. Our story starts not with an ending, but with a huge discovery. The year is 1930, over at the Lowell Observatory in Arizona. A young self-taught astronomer from Kansas named Clyde Tombaugh is staring at photographic plates, comparing tiny specks of light night after night. The guy who founded the observatory, Percival Lowell, had predicted for years that a planet X existed somewhere beyond Neptune, a mystery world he thought was messing with the orbits of Uranus and Neptune. After months of painstaking work, Tombaugh found it, a faint dot that moved against the background of the stars. It was exactly what they were looking for. The discovery was a global sensation, as the world celebrated finding a 9th planet. It felt like a massive win for human curiosity and our drive to map the heavens. The honor of naming this new world went to the Lowell Observatory, and they got over 1,000 suggestions from all over the world. But the winning name came from an 11-year-old girl in England named Venetia Burney. She suggested Pluto, after the Roman god of the underworld, a perfect name for a world so far from the sun's light, hiding out in the cold, dark depths of space. And just like that, Pluto was officially in the solar system's most exclusive club. It popped up in our culture, most famously as the name for Mickey Mouse's new dog. For the next 76 years, Pluto's status was safe. It was the smallest, the coldest, and the most distant planet, a little weirdo that we loved. We knew almost nothing about it, which just made it more interesting. It was a tiny frozen puzzle on the frontier of our solar system, the last beloved member of the planetary family we all knew. Its spot in our cosmic census felt permanent, an unshakable fact. But in science, facts aren't unshakable. There's only evidence. And as we got better at finding it, that simple picture of our solar system started to get a whole lot more complicated. For most of the 20th century, Pluto just cruised along as a planet, no questions asked. It was weird, sure. Its orbit was a really stretched out, tilted oval that for 20 years of its 248-year trip actually brought it closer to the sun than Neptune. No other planet does that. But it was our weird little planet, and that was that. By the 1990s, though, everything we thought we knew about the outer solar system was about to change. The first crack in Pluto's planetary status wasn't a new discovery, but a new understanding of its neighborhood. For decades, astronomers had suspected there was a huge, icy junkyard beyond Neptune, full of frozen leftovers from when the solar system was born. They called this theoretical place the Kuiper Belt, named after the Dutch-American astronomer Gerard Kuiper, who first proposed it back in 1951. But for a long time, it was just a theory. Our telescopes just weren't strong enough to see anything that small and that far away. That all changed in 1992, using more powerful telescopes. Astronomers David Jewett and Jane Liu found the first Kuiper Belt object, or KBO, since Pluto itself. It was a tiny world called 1992 QB1, and then they found another one, and another. All of a sudden, the floodgates opened. Through the 90s and early 2000s, observatories all over the world started spotting dozens, then hundreds, of these trans-Neptunian objects. It quickly became clear that Pluto wasn't flying solo out there in the dark. It was part of a crowd. A massive, sprawling, and incredibly busy crowd. The Kuiper Belt was real, and it was filled with thousands, maybe even hundreds of thousands, of icy objects. Pluto, it turned out, was almost certainly the biggest thing in this belt, the king of the Kuiper Belt. Ukitseba, still just a member of the club. This led to a really uncomfortable question. What actually made Pluto different from all these other icy worlds we were finding? Its size for a while, that was the main defense. Pluto was way bigger than any of the other KBOs we'd found. It felt like it was in its own league. But that argument was based on the hope that we had already found everything important out there. That hope was about to be completely shattered by a discovery that would trigger a crisis in astronomy and set the stage for Pluto's fall from grace. The astronomer at the center of this next chapter is Mike Brown, a professor at Caltech. He and his team were using the powerful telescopes at the Palomar Observatory in California to scan the skies. And he had a feeling that something big was still out there waiting to be found. He's even said that he was actively looking for a 10th planet. On January 5th, 2005, his team found it. Or so they thought. They spotted an object moving slowly across their images, even farther away than Pluto. The first look at it was stunning. This new object, which they temporarily nicknamed Xena, after the warrior princess. This thing was a real heavyweight. The discovery was a huge deal, and Brown's team knew it. They kept it quiet for months while they double-checked their work, even discovering that this new world had its own moon. But the news eventually got out, and the world of astronomy was thrown into total chaos. The object was later given the official name Eris, after the Greek goddess of discord and strife. And it absolutely lived up to its name. Eris created an unavoidable problem. Pluto was a planet, then Eris, a round world orbiting the sun that was even more massive, had to be a planet too. That meant we now had 10 planets. But what about other big objects they'd found, like Haumea and Makemake? They were also large and round. Should they be planets? All of a sudden, we weren't debating 9 or 10 planets. We could be looking at a solar system with a dozen or 50 or maybe even more than 100 planets. The very meaning of the word planet, a word we'd been using for thousands of years without a strict scientific definition, was officially broken. It was a term based on tradition, not science. Astronomers couldn't ignore the problem any longer. They couldn't just add Eris to the list and move on, because they knew more and more of these worlds were going to be found. A clear, official definition of what it actually means to be a planet. That job fell to the International Astronomical Union, or IAU, and their decision, in the summer of 2006, would change our solar system forever. The final act in Pluto's story as a planet took place in Prague. In August of 2006, the International Astronomical Union was holding its big global meeting. And for the first time ever, they were going to vote on a scientific definition for the word planet. The stakes were incredibly high. How do you write a rule that keeps the 8 planets we all know and love, but doesn't throw open the doors to dozens of others? After a lot of heated debate, they put a resolution to a vote. It laid out 3 conditions that an object has to meet to be called a planet. This 3-point checklist was meant to be the final word. First, the object must orbit the sun. Simple enough. Earth orbits the sun, so it's a planet. The moon orbits Earth, so it's a moon. Pluto clearly passes this test. It's been going around the sun for billions of years. Second, the object has to be massive enough for its own gravity to pull it into a nearly round shape. This is just a fancy way of saying it has to be big enough to not be lumpy and potato-shaped like an asteroid. Again, this makes sense. Earth is round, Jupiter is round, and we knew from telescope images that Pluto is also round. So, Pluto passed test number 2. 242. It looked like our 9th planet was safe. But then came the 3rd rule. This was the one that changed everything. The final rule says a planet must have cleared the neighborhood around its orbit. What on earth does that mean? It means that as a planet travels, its gravity has to be strong enough to completely dominate its orbital path. It either boots other objects out of the way, pulls them in as moons, or swallows them up. A true planet is the gravitational bully of its zone. Earth is a planet because its gravity controls everything in its path. Same for Jupiter and all the others. They are the undisputed masters of their orbits. And this is where Pluto failed. And it failed spectacularly. Pluto has not cleared its neighborhood. Its orbit is actually dictated by the massive gravity of its neighbor, Neptune. And instead of being alone, it shares its space with thousands of other icy objects in the Kuiper Belt. Pluto isn't the master of its domain. It's just one resident in a very crowded cosmic subdivision. For the same reason, Eris failed this third test too. The vote was held. Of the thousands of astronomers at the conference, only 424 were actually in the room for the final vote, and the resolution passed. Just like that, the solar system was officially down to 8 planets. Pluto was moved into a brand new category, a dwarf planet. This label was made for objects that are round and orbit the sun, but have not cleared their orbital neighborhood. In one single moment, decades of textbooks, classroom posters, and our own memories became outdated. The decision was made, but the fight was just getting started. The IAU's decision was not exactly met with quiet applause. It triggered an immediate and massive public outcry. The demotion of Pluto felt less like a scientific update and more like kicking a beloved pet out of the family. People had grown up with 9 planets, and taking one away felt like someone was trying to edit their childhood. The debate went from scientific journals straight to newspaper headlines and late-night TV. There were actual protests. Petitions were signed by hundreds of professional astronomers who hated the IAU's decision, arguing the vote wasn't fair and the definition itself was just plain bad. The states of New Mexico, where Clyde Tombaugh lived, and Illinois, where he was born, passed resolutions officially declaring that Pluto will always be a planet in their skies. California's state assembly even called the IAU's decision a scientific heresy. A strong counterargument came from planetary scientists like Alan Stern, the head of NASA's New Horizons mission to Pluto. His point is pretty simple. Where something is shouldn't define what it is. Argues that a dwarf planet is still a type of planet, just like a dwarf hamster is still a type of hamster. They push for a different definition. If an object is big enough for gravity to make it round, it's a planet. End of story. Where it is or what's floating around it doesn't matter. Under this rule, Pluto, Eris, our own moon, and dozens of other objects in the solar system would all count as planets. This whole debate really comes down to what we think is more important in a definition. It's a planet defined by its own features, like its shape and geology, or by what's happening around it, like its orbit. The IAU chose the orbit, which gives us a neat and tidy list of 8 planets. But many scientists feel this ignores how incredibly complex and interesting these smaller worlds are. They worry that calling Pluto a dwarf planet makes it sound less important, even if that's not the scientific intent. But the demotion did something amazing. It got people fired up and talking about planets more than ever. And ironically, while this argument was raging, Pluto itself was about to get a dramatic close-up, revealing a world far more amazing than anyone ever dreamed. While everyone was arguing back on Earth, a small spacecraft was speeding through space on a 9-year, 3-billion-mile journey. NASA's New Horizons probe launched in January 2006, just a few months before Pluto got reclassified. Its mission was to give us our first ever close-up look at this distant, mysterious world. And on July 14, 2015, it finally arrived. The pictures and data New Horizons sent back were absolutely breathtaking. They completely changed our understanding of Pluto and left scientists floored. The tiny, boring ice ball that some people imagined was anything but. What we found was a complex, geologically active, and vibrant world that was very much alive. Instead of a dead, heavily cratered surface, New Horizons showed us vast, smooth plains of frozen nitrogen, an area they nicknamed Sputnik Planitia. This region has no craters at all, which means its surface is incredibly young, maybe only a few million years old, and is constantly being repaved. This implies Pluto must have some kind of internal heat, a geological engine that's still running billions of years after it formed. Nobody expected that from a world so small and so far from the sun. We saw gigantic mountains made of water ice, some as tall as the Rocky Mountains, basically floating on top of the softer nitrogen ice like icebergs. We saw proof of nitrogen glaciers flowing across the surface, carving valleys. We saw a surprisingly complex atmosphere with layers of blue haze, and data even hints that Pluto might have a huge liquid water ocean deep beneath its icy shell. On top of all that, the mission gave us an incredible look at Pluto's relationship with its biggest moon, Charon. Charon is so big compared to Pluto, about half its diameter, that they don't have a normal planet-moon relationship. Instead, they orbit a point in space outside of Pluto, like 2 ends of a spinning dumbbell. This has led many scientists to call them a binary planet system, the only one in our solar system. The New Horizons flyby was a stunning comeback for Pluto. It proved that a label has nothing to do with how complex or amazing a world can be. Call it a planet or a dwarf planet. Pluto showed up and proved it's one of the most fascinating places in our entire solar system. It may not be the 9th planet anymore, but it has definitely earned a new title, the undisputed king of the Kuiper Belt. So that's the story of how Pluto lost its planetary status. It's a story about new technology, fiery debates, and how our understanding of the universe is always changing. But this debate is far from over. There are still new proposals for how to define a planet. The story is still being written, so we want to know what you think. After hearing all the evidence, the scientific arguments, and the incredible discoveries from New Horizons, what's your verdict? Should Pluto be a planet? Let us know what you think down in the comments. And if you love getting into these big cosmic debates and exploring the biggest questions in science, make sure you subscribe and ring that notification bell so you don't miss our next video. In the end, the real story here is that Pluto didn't change at all. We did. Our technology got better, our knowledge grew, and with that new knowledge, we had to rethink our old ideas. Discovering Eris and the rest of the Kuiper Belt forced us to see that the solar system was way more crowded and diverse than we ever knew. We needed a new definition to make sense of this new reality. The story of Pluto is a perfect example of how science really works. It's not a dusty book of facts, but a living, breathing process of discovery, debate, and change. Pluto may have lost its old title, but it's gained something much more interesting, a new identity as the king of a mysterious, unexplored frontier. It keeps challenging what we think we know and pulls our attention to the dark, distant edges of our solar system, reminding us that the greatest discoveries are the ones that force us to tear up the old maps and draw new ones.